Hi, and welcome back to the Save It for Parts channel. Today we're doing something a little more scientific, or at least maybe less mad scientific than usual. I have here a bucket of sand that comes straight from Sandland, our homemade underground mine. It originally comes in the form of sandstone, and this sand is what you get when you smash that sandstone. Now we end up with a bunch of this from mining our tunnels, and I thought it would be cool to see if we can turn the sand back into a somewhat solid form and use it for something like building bricks or make some solid sand castles or something of that nature. So I've grabbed an array of adhesives and other solidifying agents, yes, including beer, because I've noticed if I have a beer break open in my bag and mixes with loose sand, that stuff sets up really hard at the bottom of the bag. So we're just going to throw that in there for fun and see what happens with it. And then we're going to do some experiments, kind of compare the structural properties of the resulting mixtures. I'm going to mix the sand with the adhesives, place a little bit in each of these ice cube trays. Now, the raw sandstone by itself isn't actually all that strong. If you take it out of the ground, you mine it out, and leave it in these little chunks, you can kind of just crush it with your hands. So it'd be nice if we could invent something that's actually stronger than the original sandstone material. So I'm going to make 3 of each type of sample. So I want to find out how much sand does it take to fill 3 of these ice cube trays. And then with 3 of each sample we can try different things. We can try freezing, we can try running water over it. And the ones that survive the best or perform the best, then we can do maybe a second round of tests and vary the ratio of some of the ingredients with the sand. I also want to find out what the cost of this is. If we use something expensive and it takes a whole lot of this to make a single brick, then it's not cost effective. Now, I'm not a real scientist, so these measurements are going to be a little bit approximate. Right now my measurement is these disposable plastic spoons. They're approximately 1 teaspoon. I don't have a fancy digital scale. If I did, I could probably do this a lot better. Right now I'm just doing a little double checking to make sure I don't have any big lumps in the sand. Occasionally you get these iron concretions, and these are kind of cool. They're really solid, but they wouldn't help with this experiment, so I'm taking those out, and if I'm finding any lumps of raw sandstone, I'm breaking those up. I'm basically just going for an even saturation of all the sand grains with my additive liquid. Something like you'd use to build a sandcastle at the beach. So this is about the consistency I'm going for. In this case I used 2 teaspoons of the beer. And the rest of this beer goes to scientific purposes. I'm going to pack each of these down into sort of an ice cube, and then we'll let that sit for 24 hours and set up. For the hot glue mixture, we're going to mix the sand and hot glue in a pan and heat it up outside in case there's any weird fumes. I'm just trying to fold the sand into the hot glue, but it's going really poorly, so this particular one might not be a very viable experiment. Yes, I know you're not supposed to scrape the non-stick cancer frying pans with metal, but that's why we're doing this outside. And this is a disposable frying pan. This is starting to look like that kinetic sand that was really popular for about 5 minutes a couple years ago. I can't just pour this really hot sand, hot glue mixture into those plastic ice cube trays or it'll melt the tray, so I'm gonna have to set this up in something else. Hopefully that gunk will come out of there once it's all set up and we can do some tests on it. Alright, so next up we've got something that might actually work. Portland cement. This is probably what you'd expect to use if you were making cement or bricks or whatnot. So we're going to mix this in with the sandstone, add some water, and see what we get from that. I'm going to go with about 2 teaspoons of the cement and 2 teaspoons of water to about 12 teaspoons of the sand. I'd say that looks like sandcastle sand. And then we're doing the same with a Type S high-strength mortar. It's a little cheaper than straight Portland cement, so let's see how it compares. Next up is super glue. I don't know if I'm going to get 2 teaspoons out of this little container here, but we can try. This is one that if it works, it's going to be really expensive per unit volume. Each of these containers is about half a teaspoon, so I'm going to say I used 1 teaspoon in there. That's all the super glue I've got. I think it's just going to clump up in the middle of the sand and not really mix well, but we'll try it. Alright, so next we're going to try spray adhesive. It's going to be hard to measure this, so I'm just going to spray a bunch into the sand, and when it looks about the right consistency to build a sandcastle, we'll call it good. Well, this stuff just kind of makes a mess. This might be another one that doesn't end up working very well. Next up is 100% silicone. This next mix is some 2-part epoxy. I'm sure I'll get plenty of comments about you should have mixed this differently, or you should have done this, or you should have added this other stuff, but just kind of winging it here, and we're going to see what happens, and you can always improve this in a part 2 video. This one's going to be wood glue. So for this last mix of this batch anyway, I'm using part of the local clay strata that comes from Sandland that's mixed in with the sandstone. So that line of blue is a local clay, and we're going to try to extract some of that and mix it in with the sand and see if we can make something out of that. It comes in these kind of harder layers. This is technically sandstone here, but it's mixed in with more of this clay and some iron and other stuff. This might actually need some water added as well. Not really sure yet. I've never actually worked with the clay. Okay, we've got all our mixes together. I'm going to let those sit for 24 hours and then come back and run some tests on them. So it's been about 24 hours now, so let's get these sand blocks out of the ice cube trays. I guess the first test is, can we even get them out, and do they hold together when we bring them out of here? Alright, so we can see immediately that our number 5 mix just crumbled, so that didn't work at all. Number 6 mix is still stuck to the plastic, so I think that was the spray glue. Well, some of these came out of the ice cube trays really well, and some obviously didn't. To try to get these out without destroying any of them. So we can see a couple immediate failures. Number 5 was the super glue. That did basically nothing. That just turned into sand again. Number 9 here was the wood glue, and that set up okay on the surface, but then under the surface, remember these were this way up in the ice cube tray, underneath the surface there was no adhesion, it's just sand under there, so nothing really happened with the wood glue. Number 11 is that natural clay mix. I've got some failure here. Now some of my epoxies and other glues are looking okay, and then some of my cements and mortars are looking pretty good. So we're going to see what happens with those in a strength test next. So for this not all that scientific strength test, we're going to see how many, if any, of these bricks can each of our sandstone ice cubes support. Starting with number 1, the beer cube. So that would be 0 bricks. Beer is not a good adhesive for sandstone. Number 2 is the hot glue mix. And 3 bricks. Actually, I have 3 identical bricks like this, so I'm just going to use that as a baseline. If we want to go further with the strength test, we'll do some more mixes in the future. Portland cement and sand. And it is supporting 3 bricks. We've had a little bit of sand loss around the bottom because there's some sharp edges from the mold. but as a whole it is holding up 3 bricks. Next up is high strength mortar. 0 bricks, at least in the ratio that I used. That spray adhesive, these set up really weird. There were a lot of strands and gunk, and I don't really like working with this, so even if it performs well, it's not great to work with, and I don't see a lot of future for it. And 3 bricks. Next up we have 100% silicone. That is also showing some deformation, but does seem to support 3. Number 8 is the 2-part epoxy, and that survives 3 bricks. Number 9 is the wood glue, which has already had structural issues even before getting any weight. And that takes essentially 0 bricks. The wood glue, again, really only adhered to about half the sand here, and it's not very strong. It's kind of like taffy, so I'm going to say that is a 0 brick support. Alright, now number 10 here is kind of a control. This is just a block of raw sandstone, and it's a little difficult because it's an awkward shape, but we're going to do our best to stack some bricks on here. So raw sandstone by itself, straight out of the ground, will take at least 1 brick. 1 brick only. So far we have a couple mixes that are actually stronger than the original sandstone. Last up we have our clay mixture using local clay. 0 bricks. Next up is the water test, and since we've got some rain coming today, I'm going to put my appetizer platter out and see which ones decay the most in rain. I'm also going to stick the last of my samples in the freezer for 24 hours and then let them thaw out and then test the strength again just to see how they do in a freeze-thaw cycle. I'm also doing a bit of a bonus test, and I'm only using the survivors of the first strength test. I've actually put these completely underwater, and I'll let those sit for 24 hours and see what happens. You can already see the raw sandstone control is starting to crumble. Sandstone is kind of water soluble, and you can see the spray adhesive number 6 is starting to fall apart as well. Alright, so after a pretty good rain, we noticed that our beer mixture pretty much eroded away, and our clay mixture even more so. It's almost gone. Everything else is still mostly here. Number 4 has some significant erosion at the top. Number 9 also has some erosion. The raw sandstone definitely has some erosion. You can see some of the sand is washed away there. That's kind of our control. I gave these samples a longer soaking, and this is the final result. So number 1 and number 11 we've had 100% loss of the material. Number 4 we've had about 60% loss of material. Number 6 we've lost about 40%. Number 9 we've lost about 80%. Our raw sandstone number 10 we've lost about 50%. And then as far as I can tell, 2, 3, 7, and 8 have lost very little, maybe 1% of the material. So those 4 samples seem to be the most water resistant at this point. It's been another 24 hours, and we've pulled our other samples out of the freezer. We've got some visible damage to number 4, 6, and 9. Number 11 is pretty much completely disintegrated. Number 1 is well on its way to being disintegrated. So I'm going to let these thaw out, come back up to ambient temperature, and then test the strength again to see how they've been affected by a freeze-thaw cycle. While I'm letting those thaw, I'm going to check on the ones that were submerged overnight. And they're mostly about the same as when I left them. We've had a little bit of loss from number 10 and maybe from number 6. Let's pull these out of the water and see how strong they are when they're saturated with water. Number 6, the spray adhesive. That's about half a brick. It's crushing pretty good. And our plain old sandstone control. When saturated, will support 0 bricks. Now we're testing the ones that went through freeze-thaw. What's left of number 1, I don't expect much from this. Number 2 has suffered a little more damage while it thawed out. So number 2, after freezing and thawing, has lost quite a bit of strength. It only supported about 2 bricks. That was the hot glue, And I think what happened is as it thawed, it actually warmed up in the sun, and so the hot glue content has remelted in there. Number 4 is the high-strength mortar. Number 6, the spray adhesive, and we're starting to lose it at 2 bricks here. Also suffered from the freeze-thaw and is just pretty much falling apart here. Number 9 is the wood glue, which has already sustained damage from freezing and thawing. Number 10 is our sandstone. Our number 11 mixture didn't survive freezing at all, so we're not testing it now. So this is what we have for the most successful survivors so far. I'm going to eliminate number 2 because while it survived rain, saturation with water, and freezing, it did not survive thawing out again. It just crumbles in warm weather. That was the hot glue. I honestly didn't expect it to survive this well, but it did finally fail in the hot weather test. So that leaves Portland cement, which you'd kind of suspect because cement plus sand is basically concrete, so this is pretty strong. 100% silicone plus sand works really well. And then number 8, our 2-part epoxy sand works really well. I would like to note that the silicone kind of looks the best from an appearance standpoint. This looks pretty close to what the raw sand looks like. So if I was going to make a 3D sand sculpture, I would probably use 100% silicone to mix in and then sculpt it and let it set up. So I'm a little bit curious to do some additional tests with these, such as fire resistance. If we were going to make bricks out of these and make like a fire pit, how would they survive that? This is kind of a bonus round at this point, just to see what happens. This is outside of my original test parameters. Well, the cement one holds up okay. Gets a little crumbly after it's been hot. Next is our 100% silicone. That makes a very poor fire pit material. And this is our 2-part epoxy. This one is also somewhat flammable. Alright, so we have our extremely scientastic graph here, which has then been translated into Google Sheets so that we can do math and things to it. And here are the results. So I've graphed these where the left-hand side is better, the right-hand side is worse. So for dry strength in the initial tests, the winners were the spray adhesive, Portland cement, hot glue, epoxy, and silicone. For the rain resistance, we had very similar winners. Freeze resistance, we had again very similar winners. For strength after freezing and thawing, we had Portland cement, 100% silicone, and epoxy as the winners. For the strength of waterlogged material, again very similar outcomes. And then in the cost, and I calculated this as the cost per each of those little ice cubes that I made, and this is scaled in cents. So the most expensive was super glue. I went through 2 entire containers of super glue at about $2 each. That one actually performed the worst. It crumbled immediately before even doing any tests on it. Epoxy was the next most expensive. It was around 88 cents per each cube. Spray adhesive was about 30 cents per cube. Wood glue was about 24 cents. It also did very poorly. 100% silicone has been doing very well in most of these tests, but it's relatively expensive at 12 cents per cube. Beer did poorly. It was 7 cents a cube. Hot glue was 3 cents a cube. Now we get down to the fractions of a cent. Portland cement, which did consistently very well in all the tests, is about half a cent per ice cube. Type S mortar was a little bit cheaper at about 1/3 of a cent per cube, but didn't perform very well in some of the strength and water resistance tests. And then of course raw sandstone and the clay mix made from the local Sandland clay were both free, but neither of them was very strong in the tests that I devised. As you saw in the fire resistance test, that Portland cement was the only real winner there as well. Both of the other mixtures that performed high in every other test actually caught on fire. So they're not good for certain uses like, say, a fire pit, but they might be good for other uses where the Portland cement isn't as good, such as a sculpture where you want that more yellowish color. Portland cement just looks like cement. It's kind of gray. If you want to build something like a permanent sandcastle, you might want it to look a little more like sand. I did notice that the 100% silicone adds a slight odor to the final product. If you hold it right up to your nose and sniff, you can definitely get kind of a rubbery smell. So what does this all mean anyway? Well, Portland cement is a really good way to solidify sandstone, and we could have expected that because sand plus cement is concrete. So we've basically determined that concrete works really well as a way to make sand into a building material. And all of these other ones were fun to try out. Some of them did work, like the silicone and the epoxy, but they're more expensive and don't hold up as well to things like fire as the cement does. Now, they do have their own uses, like doing sculpture, and I might actually do some sculptures with those. But if we're going to be building anything, I think we're going to be mixing Portland cement into the sand and then using it like concrete. There are a few other additives that I'd like to potentially try that have come up as possibilities during the course of these tests. And some of them I just didn't have space for. I ran out of ice cube trays, or I didn't have the materials on hand. Some of those things include lime, maybe soda lime, which also absorbs CO2, so that could be an interesting thing to use as both a CO2 scrubber and a building material. Gypsum is another possibility. I don't think it'll be very waterproof, but we can see how it does for strength. And then there are some gimmicky, as seen on TV, spray products like truck bed liner. Yeah, it's a little jokey, but we've been experimenting with those out at Sandland for some other things, so if we can find a can of it sitting around, maybe I'll use some of that for a future test. So that will probably be another video. Stay tuned for that one if you're interested in this kind of redneck science. If you're not interested, I apologize for the boring video filled with graphs and materials testing. And check out my other videos for things that are probably more interesting. If you did stick with me through this whole thing, thanks for watching, and we'll see you next time.